Here is another method which has to do with partial fraction decomposition, and this involves long division as well. You know, so far we considered rational functions p divided by q, where the degree of q is small, so the degree of q is less than the degree of p. But what happens if this is not the case? If this is not the case, we have to do long division first. So meaning that we divide the higher degree polynomial p by a lower degree polynomial q to find another polynomial s. And then we keep the rest, which is r divided by q, where the degree of r is smaller than the degree of q. And then for this rest, we can do our partial fraction method. I know, this sounds complicated. So best is we do an example. Here we go. So I have the function 4x cubed plus 3x plus 2 divided by x squared plus x minus 2. And here you see the degree on the top is 3 and the degree on the bottom is equal to 2. So it's exactly the case where the degree in the numerator is larger than the degree in the denominator. To solve this, as I indicated, we need to do long division. Who remembers long division? So for long division, we write down the divisor, x squared plus x minus 2, and then we find out how often this is inside 4x cubed plus 3x plus 2. And now this is one way to write down long divisions. There are other ways as well. So we wonder, how can we make an x squared into a 4x cubed? Well, we multiply by 4x. And if we do this, then we get 4x cubed, and we get 4x squared, and then we get minus 8x. And then we have to subtract those two lines. So we do a minus sign in front of this line here. The x cubed terms cancels. Then we get 0x squared minus 4x squared. So we get a minus 4x squared. And then the x terms, we have 3 minus minus 8, which is 3 plus 8, which is 11x, and then the plus 2 from the top. Okay, next term. So how do we get x squared, the dominating term, into a minus 4x squared? Well, we multiply with minus 4. So then we get a minus 4x squared, and then we get minus 4x from there, and we get a plus 8 from there. We subtract this, the first terms cancel. This one gives a 15x, and this minus this is a minus 6. 15x minus 6, and this is the rest of this long division. So what does this mean? This means we can write our f equals 4x minus 4. This is a term from the top here. And the rest, 15x minus 6, which we still need to divide by x squared plus x minus 2. Okay, but now we are happy. So the degree of the bottom is higher than the degree on the top. And now we want to do the partial fraction part on the second term. So we want to write now 15x minus 6 divided by x squared plus x minus 2 as partial fractions, which means we need to find the linear factors of the denominator. So let's do that extra. X squared plus x minus 2. And if you look at it for a while, you notice you can write this as x minus 1 times x plus 2. So meaning this would be then equal to a divided by x minus 1 plus b divided by x plus 2. So we multiply by the linear factors x minus 1 and x plus 1 at the same time. And so then we get 15x minus 6 equals a. So the x minus 1 terms cancels, and we get x plus 2 plus b. Now the x plus 2 term cancels, and we get an x minus 1. And now we use Tollo's method by subbing in x is minus 2, which makes the first linear factor 0, and subbing in x is equal to 1, which makes the other factor equal to 0. If we do this, so let's say x is minus 2, and then on the left-hand side we get a minus 30 minus 6, and then the a term vanishes, and the b term has a minus 3 times b. So then we get minus 36 is minus 3b, so making b equal to b 12. And then we sub in x is equal to 1. Then on the left we get 15 minus 6, and on the right we get the a term, a times 3, the b term vanishes, and we find a is equal to, on the left we have a 9, divided by 3 is 3, so a is equal to 3. So then we can go up here and continue writing this to be 4x minus 4. This is unchanged, but the rational function now becomes a divided by x minus 1, and a is 3, plus b divided by x plus 2, which is 12. And we are able to solve this integral. So then this integral becomes the same as the integral over 4x minus 4 plus 3 divided by x minus 1 plus 12 divided by x plus 2 dx. And then I can do all of these. X goes to x squared with a factor 2, so we get 2x squared. Minus 4 becomes a minus 4x plus 3 log of x minus 1 plus 12 log of x plus 2. And guess what? The constant. Yoo-hoo! So that's how this works. To summarize, so the key is exactly this formula here. Okay, so if the degree of p is larger or equal the degree of q, we need to divide first. And then we get a division term, which is a polynomial s, and we get a rest, where now the degree of q is larger, and we can do partial fractions.